Exponential functions have this form, y equals ab to the x. So a is known as your initial value, or what happens at time 0, and b is your growth or decay factor. So for all the problems we're going to do, the first step is always to figure out what your equation is going to be. And so what I want to point out again is that a is that initial value, what happens at time 0, because if, say, we plug in 0 for x, we get y equals a b to the 0, and b to the 0 is 1, so your y equals a. So we're going to start by looking at one type of problem, which is where you have an initial value and some kind of growth or decay rate. So when I look at this, if I were setting up a t-chart, I would say, well, at time 0, my population is 5,000. So time 0 is where I'm starting. So what that tells me is that this right here is my initial value. So when I'm trying to fill in y equals a b to the x, I know right off the bat that a is 5,000. So I have y equals 5,000 b to the x. Now, b is essentially what I'm going to multiply by to go from 1 year to the next. So if I want to know what my population is after 1 year, I have to decrease 5,000 by 12%. What that means is, if I'm going to lose 12%, I'm going to have left, let's see, that's 88%. So this is going to be whatever 88% of 5,000 is. What that tells me is that my b is 0.88. So my equation is y equals 5,000, 0.88 to the x. And then from there, now that I have my model, so here's my model, now I can answer my question. I want to know what the population will be after 10 years. So when x is 10, what is y? So y is 5,000, 0.88 to the 10th. And I'm going to my calculator. So 5,000 times 0.88 to the 10th power. And that's going to be 1,392.5, which I'm going to round to 1,393 people.